Okay, so we talked about what the polar form of a complex number is. It comes from plotting it in the complex plane, right? Good problem solvers will start with a drawing, right, with a picture, with an image to help them out. -3 and then -3 radical 3. So at this point we have our real axis and our imaginary axis. So along the real axis we go over -3, and along the imaginary axis we go -3 radical 3. So it's going to go a little bit longer, right? So let's go here. Oops, sorry. I'm in vector mode with my other class. So let's put it right there. So we know that this distance is -3, and this distance down to here is negative radical 3 root 3. So we have that. They want to know what that number is in polar form. Remember, polar coordinates are not about left and right and up and down. Polar coordinates are about out and around, right? So how did we get to this point? We got to that point by rotating this far around the polar axis, okay, or around the pole. And then we got out to here by moving this distance. That distance is what we call r. Theta is the angle of rotation that gets us from here all the way around. We can find both of those if we use our trigonometry skills. Okay, I know I labeled it over here, but this is -3 radical 3. This is -3. I can find r using the Pythagorean Theorem, right? And that's what our formula is. We had this formula, we wrote this down. R is equal to the square root of a squared plus b squared. You should have that in your notes, okay? But a and b, I mean, this is just a sort of fast-forwarded version of the Pythagorean Theorem. So r is equal to the square root of this value is, well, that's b, sorry, this is a, -3 squared plus -3 radical 3 squared. All right, so if I square those values, we get r equals the square root of 9 plus, this is 27. Okay, you want to see a breakdown of that? I think I can squeeze it in over here. -3 radical 3 squared is -3 radical 3 times -3 radical 3, which is -3 times -3 is 9. Radical 3 times radical 3 is 3, which is 27. I'm not distributing, I'm just taking these numbers and multiplying them. Okay, that's a commutative property. So we have 9 times 3, which is 27. So over here for our r value, we get r equals the square root of 36, which is 6. So our r value can't be negative because it's a distance. Keep in mind, we're talking the absolute value of that point. How far away is it from the origin? So we have our r value. Our value of theta is the inverse tangent. And now that I know this is 6, I know the formula talks about tangent, but now that I know what this is, I can use any trig ratio that I want, any trig function. I could have said its cosine is -3 over 6. Because remember, we're talking about this angle right here, right? We're using that piece. I don't have a protractor to measure this entire thing. I know that at least to get from here to here is 180, but I got to find this piece so I know how much further beyond 180. So if we do the inverse tangent of, you can do b over a, but we get the inverse tangent then, if you simplify this, the inverse tangent of radical 3. Which angles have tangent values of radical 3? Pi over 3 angles, right? And that's 1/3. We know our angle is a pi over 3 angle, and if you type this into your calculator, it's going to say 60 degrees, right? We know, looking at the picture, that, yeah, sure, this is a 60-degree angle, but the entire angle is 180 plus 60 degrees, right? 240. But if we go with our knowledge of the unit circle and we see, okay, this point is in quadrant 3, and in quadrant 3 there is a pi over 3 angle, it's 4 pi over 3. So now I have the correct direction angle for this point, and I have my modulus of 6, and my argument of 4 pi over 3. So this complex number, z equals 6 cosine 4 pi over 3 plus, I'm going to say I6 times the sine of 4 pi over 3. Remember, the I and the 6, we can switch those around. I mean, you could put the I at the end of this if you wanted to. It doesn't matter. That I can go anywhere, right? Multiplication is commutative.